Hey everyone, my name is Paul Dietrich and welcome to Dietrich Education, where I talk about everything EdTech. And today is going to be about probably one of the best things you've never heard of, and it's called fluid math. So just to kind of put it out there, it's not a sponsored video. I'm not getting paid to do this. I literally just got a demonstration of fluid math by Fluid Math themselves, and I thought it was just awesome. So I wanted to share it with you. So let's get started. Fluid math is one of those things where it's just like I was looking for something that had, graphs and the ability for students, because I'm a math teacher, I teach middle school math. I wanted students to be able to interact with what they're seeing. And fluid math actually does that in a very fluid way. So just kind of, it has, just to kind of start with, it has like, your basic functionality where you can draw, right? You can draw and do all that kind of stuff. You can draw happy faces if you'd like, but you can either clear your entire selection. This is one of the cool parts. This is the first of many. You can either clear the entire screen, or you can just scribble across it and it erases. Actually, that's probably one of the most funnest things I'm doing on Fluid Math. I'll just scribble stuff and erase it. But here's actually where the really cool and fun and interesting stuff begins. If I write down a couple numbers here, let's say 2, 3, 4, 5, 6, and I'm noticing that actually with fluid math I have to make sure that I write clearly, because like for example this number 4 to fluid math, for it looks like an L, so I need to erase it. Come on, let's maybe draw a better 4. Okay, so if you notice that they actually have different colors. So if I did this, if I did 10 divided by 5, let's see if we can recognize that one. Oh, see, I mean, I have to draw this a little bit better. 10 divided by 5. I notice it kind of does that. It's the color yellow, and it's the same color as the 2 because they have the same value. They're equivalent values. So if I'm looking at this 4, right? If I have 12 divided by 3, and if I write it correctly, it's going to turn purple because the 12 divided by 3 and 4 have the same value. So it color codes equivalencies. And I'm like, wow, this is like really good application especially for like middle school and elementary school. They can, for questions that are asking, which of these expressions are the same or equivalent, this actually color codes it so it's very easy to see. So I'm just going to clear all, but also it does this. And this is also really amazing. I'm going to say amazing a lot during this video. Just watch. So if I say 2 plus 3, and I put a little arrow, it shows the expression on the bottom, but then a 5 pops up. It's a built-in calculator. Like right on the digital paper, it's a built-in calculator. So if I have -3 minus, I don't know, 6, and then put the little arrow, it comes up with -9. It's like, what? So how about 6 squared? Let's see if it actually recognizes that, but I did type that a little bit. Oh, it does. A little bit sloppy, but 36. How about the square root of 4? There it is. And if you notice too, they are all different colors because they're not equivalent in value. So let me clear the whole thing. Now, it could also do variables. Check this out. 3 times x, right? So 3x. Put the little arrow there, and it's going to, produce 3x. But there's nothing about that. It's just that single term. But if I have this, let me give a value to x. Let's say if I let x equals 0, for example, right? Well, then this actually updates because 3 times 0 is 0. So what if it's not 0? What if x is 5? Well, then this updates again because 3 times 5 is 15. It's like, what? And I was like, wow, like this literally brings interactive notebooks, the idea of that, to a different level than what I thought was possible, right? Even if I have this, let's say if we're doing graphing, right? Let's just type in slope-intercept form. So we have y equals mx plus b. And so it shows the equation on the bottom, but I can do this little swooping motion. I swoop, and it graphs it for me. It makes this graph. There's a table of values that are also on the side, but here's the best part. I can actually put in values for the slope and the y-intercept. So let's say m equals 2, right? The graph automatically updates. And let's say if I let the y-intercept equal, I don't know, -5. and the graph automatically updates. Now here is one of the best parts. I can click on this and click. Oh, I can make it a slider, and I can slide the slope so the kids can see in real time what slope does if it becomes more and more negative or more positive. And you can do the exact same thing with the y-intercept. It becomes a slider, so you can change what the y-intercept is, and it changes the graph in real time. But then I can also do this. Let's say if I had y equals 6, right? I can graph it just by swooping, and it graphs right on the graph. It produces the graph. Where I have it x equals -3. So I have x equals -3, and I swoop it onto the graph, and it graphs it. And now I have 3 different lines. I can hit the table, and here's all of them. Here's the table of values. And I'm like this is great. Like this is like, it's like, wow. Okay, so the other part to this is this. If I go to, they have a lot of different templates that you can use too. This was, oh my gosh. I had to recover after I saw this one. So we've all had that point in math where you're being asked, okay, let's say there are 2 cars or 2 trains or 2 planes, and they're traveling side by side. Let's say they're racing or, you know, whatever, and they're traveling at different rates of speed, right? At what point does car A overtake car B, or, you know, something to that effect, right? And in this case, you can actually you can doodle your car or your plane or your train. You can doodle it, name it, and assign it a rate of speed, right? So this is a sub x equals 80 times t, and this car B is b sub x equals t times t, 10 times t squared. And a lot of times kids are gonna be like, okay, what, like, I don't even know what that means, but okay. And so the best part though is there is a play button. So I hit play, and oh my gosh, it moved. That's my first thought. Oh my gosh, it moved. And then they have the slider where I can move the value of t around, and all of a sudden it becomes a little, or actually a lot more clear of really what happens when you, what t does in terms of if you put in different values of t, like what does that mean? And you can kind of visualize where they meet up. Let's say they meet up at 8, but then you have this graph where you can zoom in and you can actually see, yep, when t is 8, that's when the graphs actually intersect. And it's like, wow. It's like, wow. So this is actually just a handful, a very small handful of what the rest of fluid math is actually capable of. It's just a website. There is nothing to download. You can do this on Chromebooks. There's a collaboration feature, which means you can have multiple kids on the same page at the same time, and putting in and swooping and doing all this kind of stuff, and actually putting in and making graphs all at the same time. It's amazing. So I wanted to share that with you. There's plenty more, but depending on how many maybe people are actually receptive to this video, give it a like. If there's enough likes, then I'll make another video to kind of show and demo the other features. But yeah, it's called Fluid Math. You have to check it out, fluidmath.net. Thanks for tuning in. I'm Paul Dietrich. Thanks for stopping by Dietrich Education, where I talk about everything ed tech, and I will see you in the next video. Bye-bye.